Hello friends, my name is Murad Mouili. In this video, I give you the solution of this problem. This is the original problem from France-IOI. It's in French, as you see. This problem is from the Algoréa Contest 2013, round number 1, challenge number 5. I translate it in English. Let's read quickly the problem statement. You've been stuck on the last level bus of your new video game for several days. In order to master your game, you decide to use your computer skills to write a program that will help you to optimize the way you play. In your game, you can never go back. You can only move to the right. And each level contains powerful bonuses. In the last level, there are 5 types of bonuses. One type of bonus can appear several times within the level, which must be obtained in order. Bonus number 1 is the cloak of power. Bonus number 2, the cursed harpoon. Bonus number 3, the ebony talisman. Bonus number 4, gloves of fire. 5, the silver arrow. Without these 5 items, you have no chance against the boss. So you absolutely must recover them. Thereafter, a type of bonus will be represented by its number. You carefully noted the order of which the different types of bonus appear during the level. For example, I have in the level I have these bonuses. So in this case, we can reach the boss 5 times because in the round number 1, we can collect, for example, 1, 2, 3, 4, 5. We have to collect them in order. Okay, 1 and then 2 and then 3 and 4 and 5. Then round 2, I can collect 1, 2, 3, 4, 5. This in green here. Round number 3, I can collect these bonuses 1, 2, 3, 4, 5 in green. 4, 1, 2, 3, 4, 5. Round number 5, 1, 2, 3 on 5, and round number 6, there's no bonuses to collect. You see, we have just 1, 3, and 4. There is no 2 and 5. So I want to write a program that determines the maximum number of rounds you can do. Okay. Let's try to run this example. We make this example. I will imagine that I have a robot, or we have a robot that collect the bonuses in our place. Okay, so I will send it in the beginning of the level. In the beginning of the level, we have the bonus number 3. I can't collect it because I have to collect them in order from 1 to 5. So we go to the next bonus. We have 1. I can take 1. This one. Next bonus, we have 2. So we have collect 1, we can take 2. We go to the next bonus, it's 1, we can't collect it because we have 1, 2. So we look for 3. We go, no, 2, no, 1, no, 4, no, 3, we can take it. And now we look for 4. We cannot go back. We can only go to the right. Okay. So next is 1. We can take 1 because we have 1, 2, 3. We look for 4. We take this 4. Now we look for 5. We take this 5. So in this time, for example, the robot can raise a flag to indicate that he collected the 5 bonuses in order. This is 1 round. In this case, the robot indicate to himself, let's say, that he must continue checking because it might be another 5 bonuses. If he has found 5, it could be there's another 5. So he continue checking. 3 he can take 3, 4, 5 more. So he start by 1. So he look for 4. He take 4. Then he take 3, then 4, then 5. So here another flag, so another round. So he will be it will might that there are another 5 bonuses because he found for now he found 2. It could be there are another 5 bonuses to collect, okay, from 1 to 5. So you continue 1, 5, no, 1, yes, 3, no, 2, no, 2, yes, sorry, 3, yes, 2, 2, no, 3, no, 4, yes, 5. Okay, another flag, another round. He continued because he raised the flag. Each time he raised the flag, he continued. Okay, no, for 1, yes. Looking for 2, yes. Looking for 3, 3. Looking for 4, there's a 4. Let's see. We have another round here. 4. This is the round number 4. So we continue because he raised the flag. We continue checking. 1, yes. 2, 3, 4, 5. Another round. This is the round number 5. He continued checking because he raised the flag. Now check 1, 2. There is no 2 as you see. So at the end of the level, after 5 rounds, the flag is now raised, so he stopped checking. This is the naive approach. So every time he raise the flag and continue check. Raise the flag, continue check. Start from the beginning, continue check. Okay? This is a naive approach. This is the pseudo code of this naive approach. So this is the number of rounds. At the beginning is initialized to 0. Then we suppose that the flag is true. This is the flag, our flag. We have our flag. Then while the flag is raised, so we start check. So at the beginning the flag is not raised. So okay. The bonus we want to start from 1. And we enter the level. The level is of the length n. Okay, which means 0 from 0 to n minus 1. If the current bonus at the ith position a of I is equal to that bonus, so we add 1 to the bonus. Okay, if we found 1, so we check for 2. If we found 2, we check for 3. Okay, and we mark that bonus as taken, which means that we can make a of I equal to 0, minus 1, whatever. Okay, and if the number of bonus is equal to 6, we can ask why 6 here, because for example here, if we have found 1, it will be bonus 2, we check for 2. We found 2, we check for 3. We found 3, we check for 4. We check 4. We found 4, we check for 5. If you find 5 here, and this if statement, if the current bonus 5 is equal to 5, so bonus will be equal to 6. Okay, so that's why here, which means here, if bonus is equal to 6, which it means that we have found all the bonuses from 1 to 5. At this time, we start checking from the first bonus number 1, and we add 1 to the round, of course, CNT is equal to CNT plus 1, and we raise the flag. Okay, raise the flag when we found all the 5 ones, as we have seen in the previous presentation. And that at the end we return the number of rounds. The time complexity of this is the number of rounds times, this is the formula of the, you can say, time complexity, the formula is number of rounds times n. Okay, we have CNT rounds and we have n bonuses, so each time we check all the level to find a round. So we can say that our formula In the worst case, where we have n over 5 rounds. This is the maximum number of rounds that we can find, which means C and D is equal to n over 5. So the time complexity is quadratic here, O and big O and square. In the best case, where there is no round, which means C and D is equal to 0, so it's linear this time. It will be this code will be run. This for loop, it will be run just once, okay, just once. That's why this code gives me a tail limit exit. The optimization of this code, instead of having just one route, let's say that we have many routes to do this work. Okay, and here in this is the array called count. Count of I is the number of robots having bonuses from 1 to I. That instruction. Okay, let's send the red robot. We start from 3. We can take 3. Goes to 1. He can take 1. Here, as you see, we have here in the array count, which means here we have the red robot at position 1, which means the robot number 1 has the bonuses from 1 to 1. Okay, which is bonus number 1. Then he goes to 2. We can take 2 because we have 1. So now in the array count, the red rabbit is at position 2, which means the red rabbit here has the bonuses from 1 to 2, 1 and 2. So, and he goes to 1. He can't take 1 because he looked for 3. Okay? So you will send another rabbit to take that 1. Let's say the green rabbit here. Okay? So we take that 1 and we update the array count. At position 1, we have the green rabbit, which means the green rabbit have the bonuses from 1 to 1. And both now go to 2. Who can take 2? Yes, of course, the green rabbit, because he has 1. And now we have 2 rabbits, the green and the red, have bonuses from 1 to 2. Now both go to 1. They can take 1 because they have 1 and 2. So we send another rabbit. Let's have the purple one to take that 1, the bonus number 1. He take it and update the array count at the position 1, which means the purple here rabbit have the bonus from 1 to 1, the bonus number 1. Now all of the 3 rabbits go to next bonus, which is 4. No one can take 4 here because there is no rabbits have the bonuses from 1 to 3. We have the purple from 1 to 1, and the green and the red rabbits have the bonuses from 1 to 2. No one have 3, so no one can take 4 here. So we go to 3. Who can take 3? The green rabbit or the red rabbit. He can take them. He can take the bonus number 3. Let's say red. He takes 3. So now the red rabbit have the bonuses from 1 to 3. They go to 1. Who can take 1? No one, because the purple rabbit look for 2, the green rabbit look for 3, and the red rabbit look for 4. So we send another array, the blue one. So 1 is taken by the blue rabbit. So we update this array. So we have now 2 rabbits have bonuses from 1 to 1, which is the purple and the blue one. We'll go to 3. Who can take 3 here? Yes, only the green rabbit, because the green rabbit has bonuses from 1 to 2, as you see here in this array. Okay, so you take 3. Now the green rabbit has have the bonuses from 1 to 3, same as the red rabbit. Who can take 2? Yes, the blue or the purple one, because both have one bonus number 1. Okay, so let's say we send the purple, we take it. So, and now the purple rabbit have bonuses from 1 to 2. We go to 2. Who can take 2? Yes, only the blue rabbit, because he has bonus number 1. Okay, we go to 4. Who can take 4? Which rabbit? The green or the red? Yes, the green or the red. So we send, for example, the red here, and the red now has the bonuses from 1 to 4. Okay, we go to 3. Who can take 3? Yes, the purple or the blue rabbit. Let's send the purple rabbit, and now the purple rabbit have the bonuses from 1 to 3, same as the green rabbit. Now we go to 5. Who can take 5? Yes, the red rabbit. Now the red rabbit have all the bonuses from 1 to 5. So he stopped there, and the rest continue. Okay, who can take 3? Which rabbit? Only the blue one. Yes, because he have the bonuses from 1 to 2, as you see in the count array. Okay, so now we have 3 rabbits having bonuses from 1 to 3, and 1 rabbit have the bonuses from 1 to 5, which is the red one. They continue. Who can take 4? Yes, the blue, the green, or the purple, one of them, because all of them have bonuses from 1 to 3. So let's say the green one here. So the green one have bonuses from 1 to 4. We go to 5. Who can take 5? Yes, only the green rabbit. So now the green rabbit have bonuses from 1 to 5, same as the red rabbit. He stops there, and the blue and the purple rabbits will continue. Who can take 1? Yes, no one of the running rabbit now, which I mean the blue or the purple. So we send another rabbit. Let's say the orange rabbit here. He can take 1. So the orange rabbit have the bonuses from 1 to 1. They continue all the 3 rabbits, the red, the orange, the purple, and the blue. Who can take 4? Who can take 4? Yes, the blue or the purple. Let's say the purple one. We take 4. So now the purple rabbit have bonuses from 1 to 4. They continue to 2. Who can take? Which rabbit can take? Which rabbit can take 2? Yes, the orange. Okay. Who can take 5? Only the purple. Yes. Now we have 3 rabbits having bonuses from 1 to 5, the purple, the green, and the red. Okay? We stop there, and the rest of the rabbits continue checking, collecting. Who can take 4? Which rabbit can take 4? Only the blue, because he had bonuses from 1 to 3. So he takes 4. We continue. Who can take 3? Only the orange one, the orange rabbit. Okay, because he has bonuses from 1 to 2. They continue to 4. Who can take 4? Yes, the orange one, because we have bonuses from 1 to 3. Sorry guys, I think I have confusion when I use have and I use has. Don't worry guys about that. Okay. So the orange rabbit can take 3. Now which one can take 4 or 5? Yes, the blue or the orange. Let's say the blue here. The blue take 5. So now we have 4 rabbits having the bonuses from 1 to 5. Red, green, purple, and blue. And he stopped there, and the orange one continue. He now is at 5. Can he take 5? Yes, because he has, or he have bonuses from 1 to 4, so he can take 5. Now we have 5 rabbits having bonuses from 1 to 5. We have the last one is 1. No one can take it, so we send another rabbit. Let's say the pink one. Okay, to my capital that goes here. Yes, we have just one rabbit having bonuses from 1 to 1. Now, what's the answer? The answer is 5, which is the count of 5. The last cell here, or the last case in the array. Okay. This is the pseudocode. First, we have our input array. Then we initialize our count array to 0, except the first index 0. We initialize to plus infinity. Why? Because as we have seen in the previous presentation, for example, if I want to check if a rabbit can take the bonuses number x, I have to check the bonus, the previous bonus, x minus 1. Okay, if there are a rabbit who have collected from 1 to x minus 1. So when I start from 1 here, so I have to check from 0. We have no bonuses 0, so at 0 we put plus infinity to say that if you want to take the bonus number 1, you can take it, because we have the previous one. We have many rabbits that have 0. Okay, no bonus. We start by the first element 3. We check if the rabbit having from 1 to 2. The answer is no, because as you see at 2 we have 0. Okay, so we do nothing there. We go to the next 1. Okay, as you see, we check here if there is a rabbit having 0. Okay, 0 bonuses. The answer is yes, we have many rabbits, so choose 1. So at this time, we subtract 1 from plus infinity, stay plus infinity, and we add 1 to 1. And we continue. Okay, to the next, we have 2. Okay, so we check if we have rabbits having bonuses from 1 to 1. The answer is yes, we have 1 rabbit, as you see. So that rabbit will be at the next position, which means instead from 1, he bounces from 1 to 1, he will bounces from 1 to 2. Okay? We will go to the 1, same here. We can take rabbit from 0 and add it. He takes 1, takes the bonus number 1. Okay? Same here for 2. Okay, we check the previous. Do we have rabbits having bonuses from 1 to 1? Yes, we have 1. So we take it and it will be now 2 rabbits having bonuses from 1 to 2. Same here, as you see. Same. Yeah. We check the previous 4 now. Okay, we check for 4. For 4, as you see, there is no. We check 3 because we are at the bonus number 4. We check, do we have rabbits having bonuses from 1 to 3? The answer is no, we have 0. Okay, so we do not know that. We go to the 3. We check, yes. At 2, we check, do we have rabbits having bonuses from 1 to 2? The answer is yes, we have 2 rabbits. So we take 1 and 1 will take 3. So we subtract 1 from here, and that one, he will take 3. So 3 become 1 here. Okay. And so on. Let's, for example, stop here. Stop here. Okay. Or here. Let's say here. Okay. So at 4, at bonus number 5, we check how many rabbits having bonuses from 1 to 4. We have 1. Okay. So that one, he can take the bonus number 5. So that one, he can take bonus number 5. So it will be 0 there, and we add 1 to at position 5. Okay, and we'll continue like this until the end of the level. So at the end, as you see, so there 1. Okay, we have to return that result. This is the code. As you see, the code, the time complexity of this code is linear, and you see it passes all the tests. I hope this problem is helpful for you to boost your logic and to understand how do we improve the time complexity of some problems.